Hey everybody, I hope you're all doing really good. So today I'm working on an iPhone 13 that was sent here because it will not turn on. This is a phone that was working perfectly fine until it was dropped and then nothing. Now it looks to me like this phone has lived most of its life in a case. You can see that we've got some smuts in one of the bottom speaker holes there, and this thing just overall has the appearance of a phone that's been really well protected. All right, so having a look to see what this thing is going to do whenever I connect a charger, we are getting 200 milliamps, 300 milliamps, 260, and you can see the screen on this phone, it's just remaining completely blank. So we're getting this weird, not really like we would see if we get a main short blip, but we are getting like a blip. It's not really striking me as a phone that's got like just a firm, hard main short. I'm willing to bet that this thing has a short on maybe a secondary power line. All right, so there's our symptoms. We got like 400 milliamp blips, and today I'm gonna rip this thing apart and see if we can fix it. Oh yeah. Aside from the fingerprints and things on the screen, I'm going to say that this phone has spent a lot of its life in a case. I do see some really little dings here along the edges, but we don't have any bends or anything like that. The bottom of the phone initially did make me nervous for like liquid damage, but apparently that was only on the case itself, and this looks extremely clean. All right, so to take this phone apart, I'm just going to start warming it up. That's hot air on about 200 degrees and an airflow of 120. Now, one thing I am starting to notice here as I look at it closer is there are some nicks and dings along the bottom side of the frame here. That's most likely going to be from somebody else's pry tool getting under the bottom of the screen. That sure does make me nervous because once in a while you will fix one of these phones, and the way I open it I don't have any issues, but once in a while after they've been worked on before, you'll fix a board level problem and find out that the OLED has a big old nasty line through it because of somebody else prying it open. The reason why I'm opening this the way that I do is because this newer model phone, these things are put together extremely well. And this adhesive, I mean, it is no joke. It is really strong. All right, this is just about up to temp. So I'm gonna close our clamperoo on there. Suction the cup down. Yeah, that's actually still put together pretty good. You can see it's starting to bow up there just a smidgen. So in addition to heat and a slight bit of upward pressure, I'm going to take a Q-tip with some alcohol on it and just kind of brush around the edges of this thing, like that. Same thing on the reverse side. So now that I've added a little bit of alcohol, I'm going to continue to heat this. Let's see if we can get it to pop loose. All right, starting to come loose a little easier now, isn't it? All right, we're going to stop right there. All right, so that's got the screen completely loose, and we're going to open it up. Right off the bat, I noticed that the battery is already loose, so somebody has already tried the battery, which I'm okay with this model. That saves me a little bit of time. And the inside is looking pretty good. My only complaint is the back side of the little sticker that was on the battery. It has actually stuck to the screen there a little bit and mucked that up some. All right, so I've got the shields out of the way. I'm actually only going to be disconnecting the battery at the moment so that we can see what's going on with everything still hooked up to it. So to test this phone, I'm going to hook my DC power supply up. That is going to get hooked up right there. All right, so here we go. I've got the power supply hooked up. I got the power supply on the screen. We're going to want to pay attention to the channel 1, the left side here on the power supply. And I'm going to turn it on in 1, 2, 3. On. All right, we are drawing an instant 3.2 amps of current. So maybe this thing does have a main short. All right, well, okay. So here we are, I've got the board out of the phone, and here is what that looks like. It is actually pretty stinking clean, although I don't think I am the first one to have that board out. I say that because the screw that retains the 5G antenna thing, that had been removed before. Now it's time for me to take some readings to figure out exactly where this board is shorted. I'm going to start with the battery terminal. So here we are looking at the board view for the iPhone 13, and since this board is so new, we actually don't have anything labeled, but we know this is the battery terminal. We can check right at the battery terminal, of course, and in diode mode, I'm glad to say ZXW does have diode mode readings, so we should get around a 0.39 when the battery terminal is normal. So having a look at this thing, I'm just going to check it with a multimeter, and the first test is going to be right out here at the battery connector, and I'm doing red probe on ground, black probe to do the probing. At the battery connector, I am getting a 0.37. That is a completely acceptable reading. So switching back over to ZXW tool, we need to see what comes next in line. Now, I know from experience that this chip right here, this is going to be something that is related to charging. And also, you can see that the battery is only hooked to that chip. So this chip is converting battery power into our main power. Ooh, wait, we've got some battery power way over here. We're just going to ignore that. So let's look at this chip a little bit closer. If we click around, we should be able, there we go. We'll find that basically one side of it is going to be battery coming in. So here we've got battery coming in, and then somewhere on the other side, we've got a crap ton coming back out. There is a crap ton. So this is going to be our main power line here, because you can see it comes out of the other side of that chip and just literally goes everywhere. So do we have any test points? Let's switch over here and scroll around. Ooh, what do we have here? We have two nice juicy test points right at the top of the board. That means that we can use these two test points right here to test for a short, and checking those lines, we are getting, I'm getting a 0.31. We do not have a short on the main power line. That's a bit tricky because there is some other power line that's below the main power line that is shorted, and I'm going to find it here today and I'm going to fix it because this customer has requested for this phone to either be working or the data to be retrieved. All right, so first is going to be this pesky sticker on bottom. I'm only doing this so that I can get a better look at it with a thermal camera. All of these stickers are going to shield everything, and it's going to keep me from being able to see it really well. So there we go. That's got the bottom of it cleared off. I'm going to use a bit of hot air here and warm this up because I'd like for it to come off there nice and pretty. That way I can put it right back on. Ow, it's hot. There we are. Now we can sort of see through the holes there. Okay, so for this next test, I would like to bypass this lower chip down here, and to make sure that's even going to do us any good, what I'm going to do is just put some power in right here at these two test points and make sure we still get a short first. So to do that temporarily, I'm just going to go ahead and hook us a clamp right on here to ground. And here we go. I've got the power supply on. We're set on 4 volts, and I'm just going to touch one of these test points and see if we get... I get nothing. I get no shorts at all right there. I really wasn't expecting that. Well, let's switch back over and touch the battery terminal and see if I get a short there. So here we go, battery terminal. Now I've got a little bit of a confession to make. The reason why this board is out of the phone at all is because the first time that I tested it on the DC power supply, I had it hooked up like this instead of like this, which makes it seem like it has a main short. So I've got the DC power supply hooked up to this, and we're gonna wanna pay attention to channel number 1 over here since I'm hooked up to channel number 1, and I'm gonna turn the power supply on, and 1, 2, 3, this board draws 60 milliamps and then 0. That is a completely normal reading. So now I'm going to prompt it to boot. And for boot prompt, I'm actually going to just, grab ground right here and pick us our power on pin, which is going to be this one right here. This is our power button. Here we go. 1, 2, 3. On. Okay, we are drawing an instant 2 amps of current. So the board does actually have a short, but it's not a short on a main line that's powered all the time. This thing has a short on a line that powers up after the boot prompt. So to figure this out, I'm going to go straight for a thermal camera and see what that's going to tell us. All right, so here's what this board looks like with a thermal camera. I'm going to try to bump the power on pin here without using a microscope, which is actually really difficult to see. Missed it that time. All right, there we go. We jump to an instant. 2 amps of current. Okay, let's back up just a little bit here. You can see that we had the main power management chip under here getting hot, but then we've also got a spot right up here at the corner of NAND getting hot. This is a fault that I've actually ran into quite a few times on the iPhone 13. I can't believe I just took the board out of this phone to solve this problem. It would have been a lot worse if I had removed the battery, but I didn't. So let's just get right on in here and fix this problem. There is a capacitor right up here at the corner of NAND. It is actually just underneath this coating right here. So switching back over to the board view, if we look over here at the top right corner of NAND, we've got C99226. We don't have labels on the net name, so I don't know exactly which line that's on, but that's just going to be one of our common NAND lines. It's going to be like a 0V9 or a 3V0 or a 2V6 or whatever it is. It's a NAND power line. So to fix this, I'm just going to take my blade and peel the goop off of this thing. And right away we can see it's cracked. It's got a crack running right through it this way here. And to properly remove that component, we're just going to insert the blade next to it. And give it a little pushing. And also remember, for size reference, what you're seeing here on the screen, this is a number 11 X-Acto blade. This is the tip of a number 11 blade. It's actually a pretty small tool to be doing this with. Broke the blade. That's going to be just fine. It's now stronger anyways. We want to be very careful not to damage NAND, and there you have it. You can see that that thing is just all cracked up and shattered. Now, everybody always asks me, how come you don't test the component after you remove it? Okay, well, there it is on the bench. Now, I'm going to go ahead and show you that that capacitor is actually shorted. Meter is set to beep mode. And I'm going to touch this little capacitor here. Here we go. 1, 2, 3. Touch it. That is a shorted capacitor. It has become a conductor, and it is supposed to be an insulator. You know, it's supposed to have some gap in the middle of it, but it's shattered. So now the big question, is he going to replace the cap? Or is he going to leave the cap off? All right, so here we go. Let's get this thing all shined up and ready to receive a brand spanking new capacitor. I'm going to start by cleaning away the remainder of the glue here that is in the way. And to do that, I'm using 200-degree C air. Let's just go ahead and throw a different blade on here. The soldering iron will actually do a really good job at taking this stuff off too. So whatever doesn't come off right now, I'm just going to sort of gouge it away with the iron. Almost there. All right, let's get a little bit of flux on the situation. Or like that. I'm turning my hot air up to 340 degrees C with an airflow of 40. And I'm going to use some 138-degree alloy here. I'm not going to go all the way up to leaded because I don't want to use a whole lot of temperature on this. I want to do this with pretty low temperature stuff. Now I just got to get what's left of the old broken up cap out of the way and leave us behind some nice shiny garbage to solder a new cap down with. Why do I always do this to myself? It was perfect, and then I just had to mess with it some more. Seriously? Okay. There we are. So now I'm going to install a brand spanking new capacitor. Wait, is that the right size? Whoops. Okay, let's just throw that one aside. All right, so I'm a little bit embarrassed to say that I'm actually out of 0402 caps, and that's what I need for that. So I'm gonna snag one of these off of an iPhone 6. I'm after probably 10 microfarad, 6.3 volts, something like that. What does the iPhone 6 use for these NAND caps? So we're 10 microfarad, 15 microfarad, 10 microfarad. So most of the caps on this phone, you know, the lower voltage power line, they're 6.4 volts, 2.2, 10, and 15 microfarad. There's not a whole lot of difference here. So I'm actually going to go after a 10 or a 15 microfarad. Ah, yes, C1228. Let's grab C1228. There we are, nice and pretty. And that is going to sit delightfully down into place right here where it's supposed to fit. So we got us a not so brand spanking new capacitor that's going to go right here. Now as soon as that starts to do something good, I can let go of it with my tweezers. Right about like that. And that way I can get us some nice flux in there. Right there. And I'm going to start warming this up so that it will stick down onto the board. All right, here we go. Drum roll, please. Not too much heat on NAND. This should just shimmy right on down into place for us. Come on, baby. One side. And you mofo. Now, we want to make sure this isn't up against NAND because NAND is conductive. And I'm just going to slide me a blade in here and try to get it out away from NAND a bit. See, the flux actually has some surface tension and it keeps pulling it back over there. All right, I'm going to leave it just like that. Now, with that thing soldered on there somewhat beautifully, I'm going to clean this up with some alcohol. Ah, yes. So there we have a beautifully replaced 0402 6.4 volt, what was it, a 10 microfarad? I don't know, maybe it was a 15, but either way, it is beautiful. And now it is time for my all-time favorite, green UV mask. So I'm gonna dip a bucket in here and get me a nice bucket of green UV mask. That is a standard issue toothpick. And I'm just gonna take this stuff and glob it around here. I wanna get a little bit in between here, not too much, but a little bit. Or at least on the sides of the conductor. You know, there was glue on here to start with, is what I'm saying, and I'm just trying to put it back as much like it was whenever I first started as possible. Get some glue between these. I used a little bit too much solder on here, so it gave me some trouble getting it to sit down just perfectly on the pads the way it was before. All right, cover up our conductors. Not too much mask. You use too much, it won't be able to get the light on it to cure. And there we go. So with our mask all slopped on there, I'm going to cure that up with a lamp, just like that. All right, so this has been sitting here curing for a little while, and I'm pretty comfortable that it is all the way cured up. Now, before I go ahead and put this phone all the way back together, I'm going to test it with a DC power supply, being certain to hook my lead on there in the proper direction. So now I got the DC power supply hooked up. I'm going to turn the power supply on. Remember, channel 1 over here, and we are getting 60 milliamps, 0, as we're supposed to. And now I'm going to prompt this board to boot. just by touching the boot prompt pin right over here. And we are now getting 100 milliamps, 140 milliamps, 200. And we now have a normal boot prompt. 80, 90, 100, 10 milliamps. It has completely finished booting and now it's sort of idle. So I'm gonna go ahead and turn it off. I cannot believe I took all of this apart for a NAND short. I thought for sure this was gonna be a main short. Unbelievable. Okie dokie, I have got this phone fully reassembled. I've got some brand spanking new adhesive on the bottom of the battery. I've got all of the brackets and screws back in it. We don't want to leave this little piece of fuzz there now, do we? And now it is time to close it and find out the fate of the OLED that is on the front of here. Many times phones are sent here and the OLED has already been damaged. So you fix the no power issue and you wind up with a purple bar. And with the way I open these, I no longer damage OLEDs. You know, you only have to mess up one of these things to never, ever, ever do that again. All right, so there you have it, folks. I have got this phone fully reassembled and I'm getting ready to find out what the fate is. I'm gonna connect a charger. All right, we're drawing 60 milliamps, 200 milliamps, 400 milliamps. We have a battery charging icon. We've got some step-up current. We started down low, and as it's bringing this battery back to health, the current is stepping up as it should be. And look at there, we do not have a damaged OLED. That is actually very good news. So I'm gonna give this thing a little bit of time here to charge and come on, and I'll be back in a moment to blab and give you happy news. Hopefully it's not like boot looping or, yeah. Come on, baby. Oh, here we go. We got a Apple logo. Now I'm gonna hide the screen because I don't want you to see their lock screen wallpaper. And hopefully it doesn't boot loop or anything. Come on, baby. I need this job gone. And there we go. We are up to a lock screen wallpaper and passcode screen. That is most excellent. Oh, and it's getting LTE. I don't want this phone to begin ringing, so I'm going to pop the SIM card out of it. But that's actually good news for knowing that the board is functional. I'm going to go ahead and test the ambient light sensor. It is working, and without the passcode, I'm actually not going to be testing hardly anything else on this phone. This was a really straightforward repair, so it is going to be good to go. And also, that is going to be the end of this video. So if you like my videos, I would greatly appreciate it if you give me a big thumbs up, because that helps a lot for YouTube recommending this sort of thing. And also, if you've made it this far along and you're not actually a subscriber yet, you might as well just go ahead and subscribe, because I'm going to keep posting this sort of rubbish. So that's it for now, everybody. I really thank you all for watching, and I will see you in the next one. Have a good day.